Okay, the last part of lesson 2.9 is called joint variation. In joint variation, sometimes one quantity varies directly as the powers of two or more independent variables, but not inversely. This is called joint variation. The simplest joint variation equation is y equals k times x times z. So there is only direct, no inverse. Only direct, no inverse, and that's a joint variation. So let's do some examples so you can see how a joint variation works. It works very similar to combined variation, very similar to the direct and the inverse variations, but it's going to have more than one variable. So example 3a. The volume of a solid with a circular base varies jointly, there's your clue, as the height of the solid and the square of the radius of the base. Write a general equation to model this situation. So we could say the volume, we're reading from left to right, the volume varies jointly as, we got to have our k in there, varies jointly as the height of the solid and the square of the radius. So the radius squared. There is our general equation. If the volume of the solid is approximately 75.4 cubic centimeters, so volume equals 75.4, when the radius is 2 centimeters and the height is 6 centimeters, find k. So we're just going to plug all those values into that equation we wrote in part A. So we can say volume, which is 75.4, equals k times height is 6, radius is 2 squared. We can clean that up a little bit. We can say 75.4 equals k times 6 times 4, because we got to do the squaring. And then we can solve, keep cleaning up, we can say 75.4 equals 24k. Divide both sides by 24. And k equals 3.142. In part C, the value of k is approximately equal to what famous mathematical value? What mathematical value do we know is similar to 3.14? And we know that's pi. Right? In part D, write a variation formula using your answer to part B. So we can say volume equals, instead of k, we can say 3.142 HR squared. We're just plugging k in for that equation. Or we can say volume equals pi HR squared. And that is actually the volume for a solid with a circular base. And we know that as a cylinder. You might even be familiar with it as volume equals pi R squared H. Any one of those ways. Okay, example 3b. The volume of a solid with a circular base varies jointly as the height of the solid and the square of the radius. We're going to write a general equation to model this situation. So we're going to go volume equals k times height times radius squared. It's the same general equation as example 3a. And I just read from left to right in this problem right here. Part B, if the volume of the solid is approximately 47.1 cubic inches, so volume equals 47.1, radius equals 3, and height equals 5, find k. So we're going to plug all of this in for that equation. We can say 47.1 equals k times height times radius, and we have to square the radius. Let's clean it up, and we can say k times 5 times that radius is 3 squared is 9. Then we can go 47.1 equals 45k. Divide both sides by 45. And k equals 1.047. In C, the value of 3k, so 3 times k, So 3 times 1.047 equals 3.14, which we know is pi. So how can you express k in terms of that value? 3 times k is pi in this case. D, write in a variation formula for the situation. So we could say volume equals k, which we know as 1/3 pi, because 3k is pi, so 1/3 of pi would be k, times h times r squared. Or we can rearrange it a little more and go volume equals 1/3 pi r squared h. And we know that, part E, what well-known kind of solid figure could this be? That is the volume of a cone.